Okay, in this video, let's take a look at section 5.5. We're going to solve equations by graphing. Okay, let's take a look at our learning targets for the video. So at the end of the video, you will be able to solve linear equations by graphing, and you will also be able to solve absolute value equations by graphing. Okay, so we're looking at our core concept when we're solving linear equations by graphing. So when we have an equation that is set up in this particular way, where we have a variable term plus a constant term is equal to another variable term plus a constant term, the way we're going to approach this is we're going to set each side of the equation as its own linear equation. So the left side, where we have ax plus b, we're going to set it equal to a y value. And then on the right side, we're going to set that also equal to y. So now we have two linear equations, and this is a system that we've solved in the past. So we're going to graph each of these, and then the x value from the left will equal the x value from the right. All right, so let's take a look at our first example. So we're solving this equation here, and we're going to use graphing. So like we said in our core concept, we're going to take our first side, or the left side, and we're going to set this equal to y. So we have our first linear equation. It's y equals 2x plus 3. Okay, so since I've written this one out, let's go ahead and graph this one. So if you take a look at this, this is already in slope-intercept form. So we can see that our m is 2. So our slope is 2 over 1. Rise is 2, run is 1, and our intercept is going to occur at positive 3. So if we graph this, we're coming up here to positive 3 on our y-axis, and then we're going up 2 over 1. Up 2 over 1. Likewise, we could also say that we're going down 2 to the left 1. Down 2 to the left 1. And so here is our line. Okay, let's graph the right side. So we're going to set the right side equal to y, and we have x plus 2. So again, this one is in slope-intercept form also. So we know that the slope is 1 and the intercept is 2. So when we graph this, we're going to go up to positive 2, and then we can see that our rise over run, it's just 1 over 1. So we're going up 1 over 1, up 1 over 1. Likewise, we could say that we're going down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. Okay, and then we're going to connect the dots. Okay, so then we can see, looking at the two graphs, we're looking at the point of intersection. And if we look to see the intersection point, it looks like it's happening at -1, +1. So x is -1, y is +1. So the x value that will make this true, this statement true, is -1. So let's check that and see if that's true. So we have 2 times, and we're going to use our -1, and we're setting this equal to the second equation, which is x plus 2. So when we simplify the right, we have a -2 plus 3. -2 plus 3 gives us 1, and we're checking to see if that's equal to the right. And when we simplify the right, -1 plus 2 is 1. So that checks. So our solution, x equals -1. Okay, so on our second example, solving an absolute value equation by graphing. So we're looking at absolute value now. So this is a little bit different. If you remember back in chapter 1, when we had an absolute value equation, we had 2 solutions. So we will have 2 solutions again here when we're solving this equation. If you remember the first thing, when we had 2 absolute values, one on each side, and they're equal to each other, they were isolated, we're going to rewrite the equation without the absolute values. So that's the first way we're going to set up our system. Okay, so now we have our left side equal to the right side, and so we're going to follow example 1, and we're going to set the left side equal to y, so this is x plus 3. And then we're going to set the right side equal to y. So this is our first system. So we're going to have 2 systems here. This is system 1. So I'm going to graph system 1. So y equals x plus 3. So this has an intercept at 3, and the slope is 1 over 1. So the rise is 1, the run is 1, Likewise, down 1 to the left 1. Second equation, we have an intercept at 1 and the slope is 3. Okay, so when we look at these two lines, so the system here, we can see that the point of intersection is occurring right here. And if we look at our x value, that's over on a positive 1, and our y value looks like it's up 1, 2, 3, 4 units. So it's 1, 4. So the solution to this system is going to be x equals 1. Okay, so that's one of our solutions that we have. Now we need to find the second solution. To find the second solution, we're going to go back to our original equation and we need to look at the negative. So we have this set up without the absolute value. Now we're going to set up x plus 3 equals, now we're going to put negative with a parenthesis of what's inside on the right. Okay, so we're setting it up two different ways. We're going to look at the left side, so we're going to set our left side equal to y. So we have y equals x plus 3. And then the right side, we're going to set this as y equals, and before I rewrite this, I'm just going to distribute the negative. So this is a negative 3x minus 1. So let me graph the first equation. And if you notice, the first equation is the same as the red line. So this lavender line is the same as the red line. So that's going to be this line here. And then I'm going to graph this orange line. So the orange line has an intercept at -1. And then the rise over run, so it's going to go down 3 units to the right 1 unit. Likewise, we could say it's going up 1, 2, 3 units to the left 1 unit. And if we look at these two lines, so we have our orange line and the lavender line, we can see that the point of intersection here is -1 and we're up 2. So the x value for the intersection of these two lines is equal to -1. So like we said, absolute value, we're going to have two solutions. This is our first system, and this is our second system, and then we're just solving for our points of intersection.